Okay, friends, we're going to continue our look at Math 12 Trig Functions. This is the BC curriculum. And I am Timothy Spray from Math Beacon and Oak Bay High School in Victoria. So what we're going to look at today is reference angles and exact trig ratios. And in our Math Beacon guidebooks, 18 to 25 will provide great support. I like these questions on Go Formative that I've set up for you. And these are some good essential questions to look at between 18 to 25. As always, this is a bare minimum. These questions are letting you know what you know and don't know. So do what you need to make sure you are a master. So let's get right in with reference angles and exact trig ratios. So here we go. So we've already looked at radians, we've defined coterminal, we've defined standard angles and standard position, and trig ratios. Today we're going to look at reference angles and exact trig ratios. So what is a reference angle? Define special triangles and determine exact trig ratios. And when are the ratios positive and negative? So the first thing we need to do is just define reference angles. So a reference angle is the shortest distance between the x-axis and the terminal arm. So here's the reference angle. This is 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 not the reference angle. This is not the reference angle. This is not the reference angle. The reference angle is R, 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 R. There you go. Now let's see if you've followed that. If sine theta equals 0.5, how big is the angle? Please press pause on this video, answer this question to the best of your ability, and then let's check in. So please pause the video. I have a feeling a lot of you said 30 degrees. And if you said 30 degrees is the answer, you would be no better than this goalie, okay? He took his eye off the ball. Here's the thing. Remember that with the sine, if the ratio is 0.5, there are many places inside the Cartesian plane where, I got to show you this, I missed it. Yeah, there are many places in the Cartesian plane where the reference angle is 30. So that's 30. If the angle is 150, then the reference angle is 30. If the angle is 210, then the reference angle is 30. If the angle is 330, then the reference angle is 30. Can you see that each of these would provide a ratio of 0.5? Sometimes it's positive in the quadrant 1 and 2, and sometimes it's negative in quadrant 3 and 4. So the best answer to this would be, the answer would be infinite solutions. The two solutions that we can find and we'll be able to find throughout this section would be at 2, 6, negative. The answers here would be negative 210 and 150 degrees. And we'll explain that later in the class, how we get that. But this question was more designed to let you know that you might not know everything you thought you knew. Okay, another thing just to mention is this is called a general solution. So if we wanted to find all the solutions for the sine of theta equals 0.5, it would be 30 plus 360 multiplied by n, where n is an element of the integers. Most people would use the capital letter Z, but I'm I'm out there and I wanted to use a letter that started with integer, the I for integer, but Z is the traditional letter used. So it would be 30 plus 360n and 150 plus 360n. Not to worry, you're not ready for this solution yet. This was designed to let you know that there's something to learn. So please stay tuned. Here we go. So what are the possible side lengths? I think we've already discussed this, that if you take an equilateral triangle, if you call all the side lengths 2, if we cut it in half, then that makes this length 1, that length 2, and by Pythagoras, root 3. On a 45-45 triangle, again, if you have a triangle whose side lengths are exactly this, the angles are the same length, then these have to be the same length. So if this were 1 and this were 1, then the hypotenuse by Pythagoras is root 2, which means we have our special triangles, and our special triangles are 30, 60, 90, and 45, 45, 90. So first thing I'd like you to do is draw an angle 30 degrees in standard position and state the reference angle. So please complete all these questions to challenge 1 and then press play in the video and we'll check in together. Okay, so try all of these. So here's 300 degrees. It's in the fourth quadrant, and this is the reference angle. Reference angles are always positive. This is a 60-degree reference angle. Negative 570, well, we're going to start by going backward all the way around to 360, to 450, to 540, and a negative 570. And if we're asked to state the reference angle there, that would be whatever the distance between here and 540 is, it would be 30 degrees. Okay, draw an angle in standard position in the third quadrant with a reference angle of 60. So there's lots of ways of doing it. It has to be negative, so we're going to go here, and we just need to make sure that this distance is 60. So if that's 60, that's negative 120. So there you go. Okay, what is the same and different about sine 30, sine 150, sine 10, and so on? So I'd like you to do this exploration right now. What's the same and what's different? I'd like you to draw a picture to support your reasoning. Press pause on this video right now, do your work, and check in with me. Okay, welcome back. So when we draw these angles, we will notice that they all have reference angles of 30 degrees. We'll notice sometimes the opposite side is positive and sometimes it's negative. That means that the sine of 30 and the sine of 150 are both positive, and the sine of 210 and 330 are both negative because the opposite sides are negative. Now, explain when and why sine, cosine, tangent will be positive between 0 to 360. So I'd like you to draw a sketch to support your reasoning for this. Pause the video and check in with me. Okay, so in the first quadrant, do you notice that all of the opposite and the adjacent side are both positive? That means that sine, cosine, tangent will all be positive in the first quadrant. Okay, so they're all positive here. In the second quadrant, notice that the adjacent side is negative and the opposite side is positive. That would mean that sine is positive there, but cosine is negative. Cosine and tangent are negative. In the third quadrant, notice that they're both negative. So that means that the tangent ratio would be positive and cosine and sine would be negative. And in the fourth quadrant, you'll notice that only cosine is positive. You don't need to memorize this. You should be using your conceptual understanding of the side lengths, but if you can't do that, you could always ask Spray to calculate, and I would be happy to help you out. Okay, so let's try this. When are the ratios positive and negative? So press pause on the video and give these two questions a try. Okay, welcome back. If so, I'd like you to draw a Cartesian plane. And so when you draw that, what we're going to do is we draw the Cartesian plane, and cosine is positive in the fourth quadrant because tangent is negative in 1 and 2 and 4, and sine is negative in these two, and they agree in quadrant 4. So we must be talking about quadrant 4. So just to be clear, you're to draw the cosine. Is cosine positive or negative when tan is less than 0 and sine is less than 0? So here's where they both agree, and the same will be true with cotangent when secant is less than 0 and sine is greater than 0. So let's take a look at this one. So secant is negative in 2 and 4 and positive here and here, so it must be in the second quadrant. Okay, what are the possible side lengths? And I feel like we've already spoken of that. We've looked at the special triangles for there, and now let's dig in. So here are our special triangles. What's the exact value of sine 60? This does not mean pick up your calculator. We want to make sure that you can use and make use of the special triangles. So the sine of 60 is, if we look at 60, is opposite root 3 over 2. So there you go. And tangent of 30 is going to be opposite 1 over root 3. And you could rationalize the denominator here if you wanted, or leave it as it is. So if you wanted to rationalize, you'd multiply top and bottom by root 3. The cosine of pi over 4, which is the same as 45 degrees. I'm looking at this special triangle here, and the cosine is adjacent 1 over root 2. And determine, okay, so now let's get into this. This is going to be a little bit more tricky. Determine the exact value of sine 300. So in order to play with this, you need to figure out what the reference angle for this guy is. You need to know which quadrant you're in and which special triangle to use. So good luck here. Pause the video, give it your best go, and then let's check in. Okay, here's how I like to think of it. First off, the answer is not negative 0.866. That is an approximation. So what we're going to do is we're going to draw the angle, which exposes a 60-degree reference angle. We know that sine is opposite over hypotenuse. The reference angle here is 60, which must mean that we're going to have a root 3 over 2 situation. And we know that the sine of 60 is root 3 over 2. But the question is it positive or negative? Well, what quadrant are we in? We're in the fourth quadrant. The opposite side is negative. So we know that this ratio needs to create a negative root 3 over 2. And that is the exact answer to sine 300. Let's try this one on your own. Give it a try. Okay, so I pause the video, try it on your own, and now come back. Okay, now this one, it's going to be very, very similar to the last. You're going to draw this angle. This is 60 degrees times 4, so that's 240 degrees. So you're going to draw that. It's going to be in the third quadrant. The reference angle would be 60. And you're going to decide whether cotangent is positive in that quadrant. So again, I haven't provided a detailed description for that, but I'm trusting that if you go back here and walk through those steps, you should be good to go, and the result would be 1 over root 3. And don't forget, you can rationalize that if you would like. Okay, let's look at one more. If the terminal arm of angle x passes through the point 3, -4, determine the value of cosecant x. Look, we've already done this problem numerous times in the last lesson, so please go back to the last lesson. That would be Trig, the Trig lesson part 2, and that will provide you the support you need there, but the answer is -5 over 4. And again, the suggestion here would be to draw a really good drawing with a Cartesian plane, plot that coordinate at 3, -4, where are we? 3, -4, which is in the fourth quadrant. For cosecant, you're going to need hypotenuse over opposite, so you're going to have to find the hypotenuse using Pythagoras. So again, that's not the detailed solution you might have been looking for. Please go back to the last video to find that detailed solution. If the terminal arm passes, okay, so there you go. If angle x is in standard position and sine of x equals 0.5 and secant's greater than 0, determine the value of tan x. Wow, what a mouthful. Pause the video. Okay, coming back. I don't know if I put a detailed solution to it. I did not. So again, what you want to do here is draw a Cartesian plane. Secant is bigger than 0, which means we must be talking about quadrant 1 and 4. And sine is positive, so that must mean we need to be in 1 or 2. So we have to be in quadrant 1. We can use this to figure out, we know that the side lengths of this would be 1 over 2, and we can use that to determine the other pieces needed to find the tan value, which is going to be 1, determine the value of tan theta, which is going to be 1 over root 3. Okay, so we can use that information there. So again, that was not the detailed solution some of you may have needed. Please draw this picture very well, and you eliminate quadrants because you know secant is positive in 1 and 4, and sine is positive in 1 and 2, so it must mean we're in the first quadrant. And you can use what you know about the special triangles with those side lengths to answer that problem. Okay, so I have a note here for you to go back to the last lesson here, just to make sure you covered those questions. Okay, so here's some great questions. If you are unsure of anything, please click and complete this form. This will be for my students, not for our friends on YouTube. So please click that form there, and we can respond to your questions. So that's the end of the clip, and I hope that this helps you make sense of this great chapter.